Yay, starting chapter 4. So by the end of 4.1, you should be able to graph quadratic functions that are already in standard form. Okay, so I know we've already been dealing with quadratics with today's class, but I want you to have in your notes that standard form is y equals ax squared plus bx plus c, and a, b, and c are just numbers, remember, and a cannot be 0, so that's standard form. And the graph is called a parabola once you sketch it. And so moving on, those are just two terms I wanted to make sure you had in your notes. And we went over this today with our activity, but as you can see here, when you change the coefficients, it changes, it gets narrower, wider. With this one, when the coefficient of a is negative, then we know that the graph or the parabola is now upside down. And more of the same here. Okay, so this is what you really should have in your notes as the conclusion part of today's activity. It's really important that you know that the graph opens up if our coefficient is in front of the x squared is positive, and if our a value is negative, then our parabola will open down. So what this second bullet is saying is, well, remember our, oopsie daisy. So our parent function, y equals x squared, is just our normal parabola, right? That should hit at the vertex. It's saying that if we have a coefficient in front of our x squared, so say we had y equals 2x squared, well, since 2 is greater than 1, this will be narrower. Okay, so this is our red one. But if we had y equals 1/2 x squared, well, this is going to be wider. So basically, if we have a fraction in front of our x squared, it's going to be wider than our parent graph. And if we have a number that's greater than 1, it's going to be narrower. The other really important note is that the vertex, the x-coordinate is negative or opposite b over 2a. So if b was negative, to find the x-coordinate, we'd take the positive b over 2 times a. But if b is positive, then we take negative b over 2a. So it's just the opposite sign of b divided by 2 times our coefficient in front of x squared. And so once we know our x value for the vertex, that is also going to be our line of symmetry. So in these graphs up here, you could see that, oh, I don't want that. So this dot right here is our vertex, and you can see that maybe it's 2, negative 2 on the x-axis. So then you know that this line of symmetry is going to be x equals negative 2, because our line of symmetry is always in line with our vertex. That's the nice thing about parabolas, is they're symmetrical. Okay, so the last part says the y-intercept is c. That's important. So in our original up here, our c value is where it crosses the y-axis. So we should have all of this in our notes, and hopefully we discovered it today with our activity. I just wanted to go over it real briefly here so that you have it in your notes. Okay, so on to the new stuff, graphing the function in standard form. So what I first like to do is identify my coefficients. So my a is 2, b is negative 8, and c is 6. Okay, so I have my a, my b, and my c. So step 1 says we need to find out if it opens up or down. So is our parabola opening up or is it opening down? Well, look back at your notes. how do we find if it's opening up or down? Well, we look at our a value. So is a positive or a negative number? And 2 is positive. That means our parabola is going to open up. And the next step says find the vertex. So back in your notes, it says to find the vertex, the x value is opposite b over 2a. So my b is -8, and the opposite of -8 would just be 8, divided by 2 times my a, which is 2. So my x-coordinate will be 2, right? 8 divided by 4 is 2. Okay, so I have my x value, but now I need my y value, okay, because we want an ordered pair as the vertex. So I have half of my ordered pair. I know my x, but I want to know my y. So what I'm going to do is use my equation that I have, and I'm going to substitute in my x value, which is 2, and solve for y. So I have 8 minus 16 plus 6, and so I'll get y equals -2. Okay, so I know my y, and I know my x, so my vertex is 2, -2. Remember, the vertex is either our bottom point or our top point on our parabola. In this case, it's our very bottom point since our parabola opens up. So now that I have my vertex 2, -2, I can plot that on the graph, which they've done over here for us. And they've also plotted the axis of symmetry. Now remember, our line of symmetry will always go through the vertex. So step 4 says we need to identify the y-intercept. And remember, the y-intercept is our c value. So I rewrote it up here just to remind you that our c value is 6. So we know that our parabola is opening up. We know the vertex is at 2, -2, and we know it crosses the y-axis at 6. This point up here. Okay, we also know our line of symmetry, so we can reflect this point across the line of symmetry. So it's 2 places away from our line of symmetry. So I'm going to go 2 places on the other side of our line of symmetry, and I'm going to plot this point. So now I have 3 points, and I can draw the rest of my parabola. Okay, let's look at another example. So step 1, I always like to identify my coefficients. So my a value is 2, my b value is 6, and our c is 3. So step 1 says we need to decide if it's opening up or opening down. Well, I noticed that 2, my a value, is a positive number, so I know that our parabola will be opening up. So step 2 is we need to find the vertex. And the x value of my vertex, if you remember, is opposite b, that's a 6, opposite b over 2 times a. So let's solve this for x. Substitute in our b is 6, and we take the opposite of it. Divide it by 2 times a, which ours is 2. So if we simplify this, we get -3/2. Okay, so we know one part of our vertex, and that's the x-coordinate, so that's 1.5. Now we need to find our y. So we need to plug in our x value and solve for y. So don't forget order of operations. So we have 2 times 9/4 plus negative 9 plus 3. And we just keep simplifying. So we get 9 halves minus 18 halves plus 6 halves, which leaves us with negative 3 halves. So now I have the y value of my vertex, which is also negative 1/2. So now I need to plot this point. So I'm going to go left 1/2 and down 1/2 and plot my vertex. And remember, it opens up, so we need to decide another point. Let's look at our C value. What does our C value mean? Well, 3 is the point where it's going to cross our y-axis. So I'm going to go up 3 and plot my other point. Now remember, our line of symmetry goes through our vertex, so we're going to have this vertical line of symmetry, which is at negative 1/2. So I need to go the same distance to the left of that line of symmetry as I have on the right. So I'm 1.5 away from my line of symmetry. So I need to go 1.5 away on the left side. So this point is 0,3, right? Our y-intercept. So this point over here should have an x value, but the y value should also be 3, right? We're on the same horizontal line here. Well, it should be. Don't look at my drawing. And so what will our x value be? Well, we know that our line of symmetry is at negative 1/2, and we know that we went negative 1/2 more to the right. So this x value should be negative 3. And now that I know my 3 points, I can draw my ugly looking parabola. Okay, here's another example. I'm not going to go through it all, but just real quickly, is it going to open up or down? And how do we know? Well, to decide if it opens up or down, we need to look at our a. So a is the coefficient in front of x squared. Now, if a is less than 0, it's going to be opening down. If a is greater than 0, it's going to be opening up, like we talked about in class today. So negative 1/3 is going to be opening down. And then you would go and you'd find your vertex, you would plot that point, then you would draw your axis of symmetry, and then you're going to plot your y-intercept and pick a point across the axis of symmetry and plot that. So I would like you to try this one on your own. I'm going to rewrite it because the computer messed it up. So pause the video and good luck. Okay, welcome back. Hopefully you saw that our coefficient a was positive 1. So we'll have a opening up parabola. The next step was to find the vertex. So the x-coordinate of our vertex will be opposite b, and our b is negative 2. So we need to do the opposite. It would be 2 divided by 2 times our a, which is 1. So our x-coordinate of our vertex is 1. Now we need to find the y. So plug in 1 for our x and solve for y. And we get negative 2. So now we know our y-coordinate for our vertex. So let's actually plot that here. So we're going to go over 1 and down 2. So here's my vertex, and we decided that the parabola was opening up. Okay, the next step I would take is find where it crosses the y-axis. Now remember, it crosses the y-axis at our C value, which is negative 1. So I'm going to go to negative 1 on the y-axis and plot that point. Okay, also remember that our symmetry line is at the vertex. So to be symmetrical, we also need a point over here. And this is the point 2, -1. So I have my 3 points, and now I can graph my parabola. Hopefully yours looks something like mine. And here's the book's drawing of that same parabola that I just sketched. Just a couple of things here. They should be pretty self-explanatory, but if our parabola is opening up, such as the one on the left, then it's going to have a minimum value, right? That minimum value is going to be the y coordinate of our vertex, right? So we're just concerned about where it is on the y-axis. So remember, it's the y coordinate of our vertex is the minimum. Same thing over here on the right. If we have a parabola that's opening down, then our vertex is going to be the maximum. And again, we want the y coordinate of that vertex, right? We're concerned about where it is on the y-axis, how high or how low it goes. Okay, so this problem says, tell whether the function has a minimum value or a maximum value. Well, first we need to find if it's opening up or down. So again, we look at our a value, which is 3. Since it's positive, then our parabola is opening up. So that means we're going to have a minimum value, okay? So step 1's done. Now we need to find the minimum value. So our minimum value is our vertex. So same thing we were doing. We need to find the x-coordinate of our vertex. So opposite b over 2a. Opposite of b would be 18. And a is 3. So 18 divided by 6 should give us 3. So our x-coordinate is 3. Now we need to plug that in and solve for y. And save us some time, we're going to get -7. So our vertex is at the point 3, -7. So our minimum value, remember, is the y value of our vertex. So, oops, it's supposed to be -7. So we have a minimum value at -7 to answer this question. Okay, go ahead and try this one on your own. So pause the video. And hopefully you found that we have a minimum value at -19. So that's the end of this video. Come to class with your questions tomorrow, and we're going to be graphing more parabolas.